Okay, so student, today we are going to see the numerical example based on distance and displacement. Yesterday we have seen some cases where distance and displacement are same, or in some time it is different. Okay, so let's take one example over here. Here I have taken a journey from Sangola to Solapur. As I mentioned, if you see the figure, as I mentioned here, the route Sangola, Pandharpur, Mohol, Solapur. This is the route that I have mentioned. Total distance between Sangola to Solapur is 100 km. In between them, the stations like Sangola to Pandharpur is 30 km. Then the distance Pandharpur to Mohol is 35 km. The distance between Mohol to Solapur 35 km. So I have to mention here all these things. Now let's see if the person A goes from Sangola to Solapur in first journey Sangola to Solapur. So in that case, the distance from Sangola to Solapur is 100 km. It covers the distance from Sangola to Solapur, the total journey. So total path, the way it goes, Sangola, Pandharpur, Mohol, Solapur. So totally it is the addition of these 30, 35 plus 35, that is 100 km. Now in that case same, the displacement from Sangola to Solapur is again 100 km. In that case, the distance and displacement both are same. Now, second case is what? After that, the person reach over here, it returns back. It returns back. Suppose it comes from Solapur to Mohol. Here it takes some rest. Now in that case, what is the distance and what is the displacement? From Sangola, it goes from Solapur. So in that case, the return journey Sangola, Solapur, and then it returns back to Mohol. So now in that case, the distance is what? Sangola to Solapur is 100, and again Solapur to Mohol is 35 km. So total distance is what? 135 km. The distance. Now what about the displacement at Sangola to Mohol? Here the displacement will be the shortest path between Sangola to Mohol, that is this 30. Right now what? It is 100 and 35. In displacement what? We go directly shortcut, the shortest path. Instead of goes there and comes back, that's journey goes here and it again comes back. Instead of that what? Here more. So that is the distance, that is the shortest path, that is nothing but the displacement. So here in that case, Sangola to Mohol, the displacement is this 30 and this 35, 65 km. So here distance gets different, here displacement gets different in case of Sangola Mohol, because total path length, this 100 plus 35, that is 135. But in case of displacement, directly the shortest path Sangola Mohol, that is 65 km. Now the same person reach again to the Sangola. So now in that case, the distance will be what? Sangola to Solapur 100, again Solapur to Sangola 100. So in that case, total journey, the distance, total distance will be this 100 plus 100, that is 200 km. Now what about the displacement? Now in that case, the initial point and final point is same. The object, the person A moves from Sangola to Solapur and comes back again Solapur to Sangola. So it means what? The initial and final point is same. So in that case, the displacement is 0, because 100 minus 100, that is 0. So in that case, we can say that the person goes from Sangola to Solapur and again comes Solapur to Sangola, that is same journey. So it comes its original position. So at that time displacement is 0. Are you getting? Though in terms of distance, it covers the total length. 100 plus 100, that is 200 kilometer. We can say that it covers 200 kilometer. But in terms of displacement, it gets 0. So that is one of the case. In terms of here linear. In case of linear, we can see that linear motion, how we can calculate its distance and displacement. Now let's move towards the another example in which the distance and displacement's value. Now let's take the journey in terms of circle. Okay. In terms of circle. Suppose this is a circular track. I just make quadrant appropriate. Okay. So this is the position A, B, C, D. This is a circle. This center O. We're having this radius 7 meter. What are we 7 meter? Okay. So now here the given information is that here we have to, the example is like that, they have given this figure, circle, the round track, where they have given radius as a 7 meter, and they are asking calculate or find the distance AB, AC, AD. The distance AB, the distance AC, the distance AD, and the whole journey means it total circle A to A. At the same time, you have to find the displacement A to B, A to C, A to D, and A to A. Simply the person, this is a round track where I have make 4 points A, B, C, D. The person moves from A to B, B to C, C to D, and in that case we have to find out the distance AB, the distance AC, the distance AD, the distance A, the displacement AC, AD, and A. Now how to find out this problem or how to solve this problem? We have given only this circle having the radius 7 meter. So first thing, as we know that this is a circular track, or so in case of that circular track, it's a circle. As we know that for find out the outside, we use the formula for circle, that is 2 pi r. We are using the formula 2 pi r for calculating the distance in terms of circle, because we cannot measure by a straight line like that. So the circle outside we can calculate the formula 2 pi r. So first thing, in terms of calculating the distance AA, I will just go with this. If I complete one round, if the person moves first round in the A, the distance will be what? The radius they have given 7 meter. So 2 into pi value I can take as a 22 by 7, that we know that 22 by 7, r value as a 7, so 7 goes, it goes 44 meter. So in one round, the track, if I complete, the person completed one track of round, it covers 44 meter distance. Okay. Now go for distance AC. Instead of AB, I just go first about AC. In terms of AC distance, as what we have noticed that AC distance means like this one. It is the half part of this circle. It is the half part of the circle. As we know the formula 2 pi r, that is the full circle, it is the half part. So I cancel this 2 pi r divided by 2. So this 2 get cancelled, again pi by r, that is 22 by 7 into 7. 7 get cancelled, 22 meters. That is a general thing that easily we can calculate. That is the total round is 44 meter, half part will be the its half, 22 meter. Now what about this AB? Now as it is the full circle, this is the 1/4 part, I can say that. Okay, so in terms of AB, here I can write AB is the 1/4 part, so that is 2 pi r upon 4, so that is 2, I can say that. Pi r's value as already we know that, we get here 22, so now here this 22 divided by 2, that is 11 meter. It comes 11 meter. So this is 11 meter, this is the 11 meter in this way. Okay, this is 11, so 11, 11, 11, that is a total 44. Now what about AD? Now what about AD? First, second, third. It is the third-fourth part of total. So calculating the distance AD, I can use this third by 4 into 2 pi r. This, it gets 2 by 2, 2 into 2. So here we get 3 by 2 pi r. Pi r value already I have mentioned here, that is 22. So 3 by 2 into 22, that is, it is 11, 11 into 3, 33. So here the distance AD got 33 meters. You got how I calculate the distance, this AB, AC, AD and total A is 44 meters. Is it clear, everyone? Okay. Now interesting thing about the displacement. So now just look this, how to calculate the displacement. So first part, displacement, as we know, A, B, C, D. So displacement AA, if it completes first round, in that case, as we know that starting point and final point is same, and in that case the displacement is 0, as we know that. There is no need to make any calculation. If the object comes to its original position after the journey, the displacement will be 0. So directly I can say that here displacement is 0. Now what about the displacement AB? How we should calculate? Now let's see this properly. How I calculate the displacement AB. Okay, so as in case of calculating the distance, I go from here this journey AB. Now for calculating the displacement is what? The shortest path. So I can make a directly line here. That will be the shortest path. Now here if you observe properly, here we get a right angle triangle. What? The triangle BOA. So here this is the radius 7 meter as already given, OA. This is again radius 7 meter as given. So as we know that by the Pythagoras theorem, this AB square is equal to OB square plus OA square. So OB square, that is 7 square plus 7 square, that is 49 plus 49, that is 98. So this is what? AB square. I need AB. So that is root 98. Root 98. This is then what? We cannot get a perfect square for that. But root 98 I can write at, is it 49 into 2. So 49, you know that square root of 7. So that is, I can write here this 7 root 2. So the displacement AB is equal to 7 root 2. See that the displacement is 7 root 2. If I calculate the actual value, something, suppose this is what the distance earlier in terms of distance AB, it comes as 11 as per our calculation. If I calculate the square root of 98 something, so it comes what? 98 hundreds, that is 10. Below that value of root 2's value is nearly 1.0 something. like that. So it comes nearly up to the 8 if I calculate the actual value. So the displacement is 7 root 2. Are you getting how I calculate the displacement AB? Now the displacement AC, second term, the displacement AC. Now AC, instead of going to this journey, I go directly here. Now here there is no need to calculate this value, because what, if you observe, this AC is nothing but the diameter of circle. AC is nothing but the diameter of the circle, and as already the radius has given 7 meter, this 7 meter, so diameter is what, 14 meter. Directly I got the displacement AC. Are you reading? So that is the displacement AC. In terms of distance, it comes 22, half of that, here gets 14, again less than. So you just make the observation proper carefully. Now the AC, now in terms of, after that AD, then AD, again the same, similar, the displacement AD. Again similar, here right angle triangle is formed, here 7 meter, here 7 meter, again the same, here we will do what, 7 root 2, similar manner. Getting? So in the same, the example, the value gets are going to different, distance is going to get difference. See now if I show the distance, if I show here the distance and displacement in the same figure in terms of AA, I show the complete round, AB, AC and AD. And final, in terms of distance, it is 44 meter, displacement 0, AB, that is the 1 by 4, that is 11. Here it comes 7 root 2. AC, it comes the half part, 22 meter, it comes 14 meter. In case of AD, that is 33 meter, here it comes again 7 root 2. See that, now you can compare the distance, displacement value of the same positions. Here it is greater, here is also greater, here it is again greater, here it is again greater. Got it? This is one of the example based on this distance and displacement. Thank you.